Hello there, Algebra 2. Third day of 3.1, Solving Systems of Equations. We are solving by elimination today. Alright, this is our third and final method. Well, I can't say final, we are doing another one later on. But the third and final method for right now of solving systems. So, for solving by elimination, we're trying to add our two equations together to come up with one equation that's easily solvable to get us going. Okay, so the big thing to remember is add down. Now, just like with all the other ones here, we've started off with a level 1, a gimme that's already set to go. So by adding these together, we want to eliminate, hence the term elimination, we want to eliminate one of the variables. So we have 4x minus 3y equals negative 22, and 2x plus 3y equals 16. Okay, we're going to add down, and when we add down, I get 6x, and then these will cancel out, negative 3y and plus 3y, they cancel out. So they are eliminated, all right, elimination, you've eliminated one variable. Negative 6, okay? So 6x equals negative 6. Divide by 6, we get negative 1. Are we done? Nope. Our answer needs to be in a coordinate point, x comma y. Okay, so how can I get the y? We're going to plug this negative 1 back in to either equation, your choice. I'm going to pick the bottom one just because it's got a little bit smaller numbers. So 2 times negative 1 plus 3y equals 16. Negative 2 plus 3y equals 16. Okay, we're going to add 2 to both sides. 3y equals 18. Divide by the 3. We get 6. All right? Negative 1, comma 6. Remember, x comma y. Sometimes that gets confusing if you get the y first over here, and then over here you get your x, and people will get those crisscrossed. X comma y. Steps and process. So we want to multiply one equation by a number to get one variable to have that same number, just have the same number as it does in the other equation, but the opposite sign. All right, that's a lot of words. Let's look back up here. We're trying to create this situation where I have a 3y and a negative 3y. So that when I add them down, they're going to cancel out. So that's the goal, is to get one of the variables to have the same coefficient, but opposite sign. So the y's both had 3's. One of the 3's was positive, one of the 3's was negative, so they would cancel out or eliminate when we add down. Okay, when we add down, this should then eliminate one variable. Solve for the remaining variable, right? We got x, right? 6x equals negative 6. We had x to equal negative 1. After you get that variable, substitute that answer back into either equation to solve for the second variable. We picked the bottom one because it had slightly smaller numbers, 2 and a 16, as opposed to the 4 and the negative 22 there. All right? So they're not always that clean cut and easy. You might have to do a little work. As our first step suggested, you might have to multiply the whole line or the whole equation by a certain number to get it to work. Okay, so if I'm looking at this next one, 5x minus 3y equals 23, 2x plus 1y equals 7. Okay, I'm looking at this. The y's, I could get that to work pretty easily. Okay, it's not set up already perfect for me like the last one was, but we're going to have to multiply. Do you see here, if we just multiply this whole row by 3, then we get 6x plus 3y equals 21. All right, and then I'm going to do a little squiggle through this one, so I know not to add that one. But I still want it readable, because that might be the easiest one to substitute back into later on. Okay? So you can do one light little squiggle through there. All right, we're ready to add down. 11x, the negative 3y and the positive 3y canceled out. That's why we did this. 23 and 21 is 44. 11x equals 44. Divide by 11. X is 4. Okay, now we need our y. You can pick any of the three equations up there, because now there's three, right? There's the first two that were given, and then there was this one that was times 3. So you can pick any of them. I'm going to go with the one we crossed out, just because it's got really small numbers. Okay, so 2x plus y equaled 7. I know x is 4. 2 times 4 plus y equals 7. So that's 8. If we subtract the 8, we get y equals negative 1. 4, comma, negative 1. All right, so we had to do a little work, right? We didn't have a gimme. We had to do just one little thing. We multiplied this whole row by 3, so that way the 3y and the negative 3y would match up and cancel out or eliminate when we added down. Okay? And sometimes, this is what I would call a level 3 problem here, folks. Sometimes it's not just as easy as one thing, all right? There's no one number I can multiply to this whole row unless you want to go decimals, and we'd want to try to avoid going decimals if possible. That I can multiply to this row to get this number to cancel out, or it's not always the y's that cancel out. There's no one whole number that I want to multiply to this row to cancel out with here. Okay, so this is a bit of a more challenging problem. Okay, I want to. So you got a choice. You got a choice. Remember what our goal is. We need to get two coefficients to match up, be the same number, and opposite sign. Okay, so we got a choice here, and I'll explain your two choices. You can try to get the y's to cancel out. The nice thing about getting the y's to cancel out would be that they already have opposite signs. This y is positive, that y is negative. The drawback here is that 9 and 5, we're going to be multiplying by a little bit bigger numbers. Over here, it's 6 and 5, so maybe slightly smaller numbers to multiply by, but they're not already opposite signs, so one row is going to have to be negative, and then you'd have to distribute that negative and do some sign changes. Tough call. Okay. Well, I'm going to pick the 5 and the 6, the x's, because we haven't canceled out the x's first yet. What is the first number that 5 and 6 both go into? 30. So what would I have to multiply? And one of them's got to be negative. Don't forget that. One of them's got to be negative. So I would need to multiply this whole row. Let's go, this one's going to be the negative. Multiply this whole row by negative 5 and this whole row by 6. And that should give me a negative 30x and a positive 30x. These other numbers are going to be a little bit bigger. Okay. So we have negative 30x minus 25y. Remember, it's got to go to all the parts of the whole row. Equals negative 5 times negative 32 is a positive 160. See, we have some bigger numbers. So this is definitely a level 3 here. This is a tougher problem. Negative 54y. I didn't put my y up there. Oh, 6 times 26. 156. All right. 120, 36, 156. Yep. Okay. So, our whole point of that was to get the x's to cancel out. Negative 30x, positive 30x, when they add down, they cancel out. Boom. Okay, the y's adding down, negative 79y. Ooh. And this is going to be 316. Now, moment of truth. Did Mr. Handke make a mistake somewhere along the line? I don't have a filled out one next to me here. We're going unplanned here. Obviously, this is an older note sheet, but I usually have the answer key hanging out next to me. Okay, look at 316 divided by negative 79. It comes out nice. We have success. Y equals negative 4. Okay, now I'm out of room. I didn't leave myself enough room. Maybe, hopefully you left yourself a little bit more room. So we got all kinds of choices. We can go back and use one of our two originals or one of our two new ones to plug this y in and solve for x. I'm going to do the bottom one of the originals. 5x minus 9 times negative 4. And that's kind of why I picked it, because I do a negative times a negative. And once you do a few of these, you'll start finding out little like shortcuts like, ooh, maybe it would have been easier if I would have done that. And you'll start picking up on some things here. Negative 9 times negative 4 is going to be a plus 36. Subtract the 36 over. 5x equals negative 10, right? 26 minus 36. That's going to be a negative 10. Divide by 5, we get negative 2. Final answer of negative 2, negative 4. And the really nice thing about all of these guys is that you can tell if your answer is right away. Take your x comma y, plug them in, and it should equal negative 32. Okay, negative 2 times 6 is negative 12. 5 times negative 4 is negative 20. Negative 12, negative 20, negative 32. Boom. There it is. Okay. Yesterday we talked about some special situations. Well, we talked about it more in graphing, so that's probably 2 or 3 days ago. So those kind of come up more again in elimination. You don't really see it as much in the substitution problems just because how they have to be set up to work. But sometimes you will see it in the elimination problems of your homework. Okay, it's not impossible to have to happen in substitution, but it usually doesn't. For whatever reason, it's easier to get them to line up that way for elimination. So that's more often where you see them. Again, not impossible to happen for substitution, but I just think the book does more of them with elimination. So here we are. I see a y and a 4y. So instantly my mind goes to this. This is super easy. If this is a 4y, I just need to multiply this by negative 4 to get it to cancel out. So I'm going to go negative 4 to that whole row. Negative 12x, negative 4y, negative 48. And then when I add down, see, I was trying to cancel out the y's, but this time, when I try to cancel out the y's, it also cancels out the x's. 0 equals 0. So 0 plus 0, 0 equals 0. Everything canceled out, and it's 0 equals 0. All right, so what that means is that this is the same line. Look at 3x plus y equals 12. If I would multiply this row by positive 4, I would get 12x, 4y, 48. So when it's the same line on top of each other, they share all the points in common. Okay? When it's a true statement at the end, everything cancels out and it's a true statement. 0 equals 0, 5 equals 5, something like that. That means it's infinite solutions because they're the same line. Infinite solutions. And what was our technical term from earlier? Consistent and dependent. All right, there are solutions. There's infinite solutions, but there are solutions. And it depends on what your x is. Okay, if my x is 4, 3 times 4 is 12, y would have to be 0. So 4 comma 0 is a solution. Okay, there's an infinite number of them, but it depends on what point you have. All right, and then the other type of special problem here, guys. All right, again, I'm seeing a negative y, and I'm seeing negative 3y, so I'm like, oh, I can cancel these out. I just need this to be a positive 3y. So I'm going to multiply this by negative 3. And again, I just got excited because I saw an easy one, because this has a number by it and this one doesn't, so it's pretty easy to figure out what to multiply by to cancel it out. I wasn't even paying attention, but look what's going to happen. Negative 6x, positive 3y, negative 3 times 11 is negative 33. So now when I add down, yep, cancel, cancel. Oh, this is going to be another infinite one. 30 minus 33 is negative 3. Oh, 0 does not equal negative 3. No, no, no. Not true. No solution. Fancy word for that? Inconsistent. Okay, so what we have here would be parallel lines starting at different points. And I don't know if this is completely accurate, but it's like this, right? There's that slope. They have the same slope, right? They're parallel lines, but just this one starts here and this one starts here. And I have no idea if that slope is relative to what these are or if the y-intercepts are correct for those equations, but that's what's going on. That these two lines would have the same slope. They're going the same direction, starting in different y-intercepts, so they would actually never touch. No solutions, inconsistent. All right? So there you go, folks. Give them a shot. Be on the lookout for a few of those special cases where everything cancels out and we get 0 equals 0 or 5 equals 5. A true statement or a not true statement would be inconsistent. Okay? There's our steps and process again. If you want to, you could print this off. It's posted there for you. But you could print that off, or if you just want to write that down instead, there you go, folks. Thanks for watching. Let me know if you have any trouble next time I see you in class. Good luck.